All right, fun. So now we're going to see what it means to do multiple linear regression. Multiple linear regression refers to having multiple x values. All right, so we've got x1 and x2. So we can do it just as we were doing before, pretty much, except we're going to not use simple linear regression in StatCrunch, but we're going to use multiple linear regression. So what we have y is the wind chill, x1 is the temperature, and x2 is the wind speed. So under the stat menu, under regression, I'm going to go down to multiple linear regression. This is just going to allow me to select multiple x values. In fact, it actually allows for, the y variable, yeah. Y is my y variable, and I have to hold down shift to select both x variables. Interactions are optional. We're not covering interactions in this course, so just ignore that for now. And that looks like it. I'm just going to click compute, and I will get my model. So this is giving me the same kind of output as I normally would get. I get intercept x1, and so I get my intercept term and my coefficient. So I'm going to copy the intercept term over. So let's, 3 decimal places? I can do that. The slope for the x1, the coefficient we should call it, 1.334, and the coefficient for x2, negative 0.414. I don't have to round anything up because of the 4th decimal place isn't 5 or more. So great. So that's my model. So now let's try to see what we can do with. Draw a residual plot to assess adequacy of the model. Create the residual plot for air temperature. So what I'm going to do now is I'm going to go back to edit, and I'm going to look at the options. I'm going to do I can't just click something to plot the residuals versus air temperature from here. What I'm going to do is click here to save the residuals. What that will do is, you will see, I'm going to actually close this right here. I've got residuals in a new column. Now I can take residuals and plot them against either of my x values. So I'm asked to plot residual values versus the air temperature. Air temperature is x1. Okay, so I'm going to graph a scatter plot. X is going to be x1, my air temperature, and the y variable here is residuals. And I'm going to compute, and look at what I get. Look at that. So I can see I've got the 0 line. I think I can draw. I'm going to draw. I'm going to draw a straight line. Beautiful. I'm going to draw the axes. Oh, cool. So, so that's cool. I can look at this compared to the scatter plots. I can see it looks a little bit like, well, I'd say the closest one is D. Let's zoom in and take a closer look. Yeah, look at that picture. We've got those things very close to the x-axis. Those points down here. We've got these points up there. I think I'm hiding one. Yep, that point's there. Okay, super. So that's my residual plot. Now I'm going to plot my residuals. Let's go to options and edit this. I'm going to plot, instead of x1, my air temperature against residual, I'm going to do x2, my wind speed against residuals. And I'm going to plot it. In fact, I'm going to actually make it even closer. I'm going to make the y-axis go from negative 10 to 10. It's just fun. I'm going to make the x-axis go from, looks like we're going from 0 to 120. And let's draw that line again. The line that's going across from 0. And compare that. Well, now look at this. We can see this shape. We see a swooping shape, right? That matches what we have in choice D. This kind of swooping curve. That is actually a bit of a red flag. When we have that shape, that indicates that this is what we would call a discernible pattern. The residuals against the air temperature looked fine, but for wind speed, it looked like there was I mean, this curve indicates that there isn't a linear relationship with wind speed. It's perhaps maybe a relationship with wind speed with like the square of wind speed or something like that. So I would say that there is a discernible pattern. So a linear model is not inappropriate. That's the conclusion you need to make.